All right. Good morning. Trying to lock myself in here. Okay. All right. I am going to teach a new lesson today, but before I go on, I do want to take a look at lesson 12.2. I need you to have your books open, and I need you to take any notes that I'm going to give you right now for lesson 12.2. Page 605. 605. All right, some students are asking me, how do we know if it's the zero position or the first position? Just do the first position unless they tell you it's the zero position, or if in the content, zero position, number one. So you always start at the first position unless they're going to be clear, about it being in the zero position. Also, try to draw a table. So try to list your positions and try to list your terms, because that will help you with the initial term and the common ratio. So what I want to do, I kind of want to go through the problems and let you know what position and what's the first term and things like that. So in problem number 1, they are starting at a stage 0. So they straight out tell you stage 0. So if I were you, I would draw a table like I told you. And you're going to start with the stage 0. What comes after 0? 1, 2, 3, 4. And how many sticks are in the first one? It would be 1. How many sticks are in the second picture? 3. How many sticks are in the third picture? How many? 6. And then what? So in the first 0 position, so for the recursive rules, you're always going to write the first term for the recursive rule. We know that the first term, whether you call it a sub 1 or a, is going to be 1. And the common ratio would be 3 divided by 1, 6 divided by 3, which the common ratio is 3. So in part 2, f of 0 would be 1, right? The first term would be 1, and the common ratio in number 2 is going to be 2. So number 3, you're not going to have anything like this, but I'll just show you. In number 3, when they ask for the total length of the new branches, it would be what you found in the first one, the explicit rule, and what you found in the second one, the explicit rule, and it would be that product for number 3. So this can be written as 1/3 times 2 to the n, because this equals that, right? Because you have to deliver the power across a product. And this would be 2/3 to the n. So that's what the rule is for number 3, where n is greater than or equal to 0. All right, now in problems 4, 5, and 6, it's obvious the positions are 0. In problems 6 and 7, the position starts at 1. But I want to go to the word problems. Number 12. So in number 12, do you want to do number 12?
Can we do number 12?
So for number 12, I personally think my book is wrong. So if you were going to draw a table, I would start at 1. Excuse me. And if the starting position was 1, what would the first term be? It would be 2, wouldn't it? And what would the next term be? 4. And what would the next term be? 8. And what would the next term be? 16. So if you were going to write the explicit rule, it would be f of n is equal to 8 times r to the n minus 1, where n is greater than or equal to 1. So your rule would be, the first term is 2 times the common ratio, which we have to find, 4 divided by 2, 8 divided by 4, 16 divided by 8, would be r is equal to 2. So my book does not say that this is what I think the right answer is. The recursive rule would be f of n is equal to, what is it, r times f of n minus 1, where n is greater than or equal to 2, if this is 1. So your answer would be f of n is equal to the common ratio, which is 2 times f of n minus 1. I want you to write the rule. I want you to write the domain. And I want you to write the first term, which would be 2. So I want those 3 things. I want the rule, I want the domain, and I want whatever the first, if it's f is 0 or f of 1, in this case it's f of 1, the term is 2. When you go to solve the problem, I would use the explicit rule, just because to me it's easier. So it's different than the problem I did in class, though, because they're asking, the committee wants the winner to play 4 games. So you're not putting 4 in for f of n. Aren't you evaluating? Which is different than what I did in class. Remember, we set it equal to 1. So this is different. So this would be 2 times 2 to the 4 minus 1. You don't need that right now. So this would be 2 times 2 cubed, which would be 2 times 8, which is 16. So it'd be 16 teams. So all the problems are not the same. You have to look at the meaning in the problem, and you have to determine the content of the problem and what you're going to do, which makes sense. Okay, anybody want to ask me about this one? All right, in problem number 13, the starting position is going to be 1, not 0. Problem number 14a, the starting position is going to be 0, but in B, the starting position is going to be 1. And then in problem number 15, that is a fractal, and a fractal repeats itself. So if you notice, you start with a triangle, and then you have 3 triangles, and then you have 9 triangles. That's called a fractal. Those are somewhat new in math, It's anything that repeats itself, like the ocean, the waves, the tide. That's a fractal because it's repeating itself. And there's other things in real life that that represent fractals, anything that repeats itself. So in problem number 15, your first term would be 1. Your second term would be what? How would you make your table for 15? So your first term would be 1. What's your second term?
Is it 3?
It would be 3/4. 3 out of 4 parts. What would be your next term? 9 out of 16. What would be your next term? $27 out of 64. See what I'm saying? So when you find your common ratio, it would be 3/4 divided by 1, 9/16 divided by 3/4. 27 over 64 divided by 9/16. So when you do these, that would be 3/4, 9/16 times the reciprocal, and don't say 36 over 18. You're going to cross cancel, right? So this would be a 3. It would be 3. Sorry, what would this be? What's 9/16 divided by 3/4? It would be 9/16 times the reciprocal, right? So 4 goes into 16 4 times, and 3 goes into 9 3 times, so 3/4. 27/64, sorry, divided by 9/16. You have to change to multiply and take the reciprocal, right? So what would that be? Times what? Times
16 over 9.
So I'm going to cross cancel. See how we don't want to multiply things out? Remember a long time ago I told you we don't want to multiply things out? This is why. So 9 goes into itself once, 9 goes into 33 times, 16 goes into itself once, and it goes into this, what, 4 times? So 3/4. So your common ratio is 3/4. Okay, do you guys understand how I got this or not? The table? Any questions before I erase this? All right. In problem number 16, your starting position is going to be 0. So your starting position is 0 on A. All right. Anybody want to ask me any questions about anything? When is this assignment due? 12/2?
Tomorrow.
Okay. Okay, let's do the table then for 15b. It's another fractal. And then we'll move on. Told you, unless it's clear that the starting position is 0, just start at 1. So you start 1 square. What would the next term be? It's a fraction, right? So how many parts are colored out of how many parts? So wouldn't you have to break it down parts to see what's going on? So what would the second term be? The first one is 1 whole. What's this?
Over
How
9.
many parts are shaded? How many parts are shaded out of a total?
8 over 9.
That is correct. The next one is going to be these guys broken into 9 parts and shaded on the outside. So how many total parts is that? Well, each one has 9, so it'd be 9 times 6, right? What's 9 times 6?
54.
And how many parts are shaded? Everything but what? Everything but, that's not right. Everything but there's 9, 10, 11, 12, 13, 14, 15, 16, 17, right? Is that correct? Check for me, please, because I'm not counting, so you guys can count. Is that right or no?
Yeah, that's right.
So let's see if we can find the common ratio. So it would be 8/9 divided by 1. It would be 17 over 54 divided by what? So 8/9, that would just be 8/9. And what is 17 over 54 times the reciprocal? I don't know if it's going to turn out right. But you get the hang of what I'm saying, right? You're gonna have to figure this out so you can figure out the common ratio. Can you guys figure it out right now or no?
Birch, I don't really understand how you got 17 over 54.
Well, you're starting out with 1 square. And then the square has a piece taken out of it. So that means you have to break this down into a fraction. And this fraction is going to be what? How many are colored? 8 out of 9, right? 8 out of 9. And so then they take pieces out again. And so you have to write another fraction. And that's what I'm asking you to find. So you can either look at the book or draw a picture and tell me what this next fraction is. How many total blocks are there? So you know what a fraction is, right? A fraction is what you want out of a total number. So in this one, what we want is what's colored. That's 8 out of 9 squares. So I'm trying to ask you, because I'm not doing it. I'm asking you in the third picture, what is the fraction? What is the total number of squares? And what you want goes on the top. Did you figure it out?
I don't know if it's right, but I got 12 over 81.
12 over 81. Well, let's just see if it's right. You're going to take 12 over 81 and divide by 8/9, and you should come up with a common ratio of 8/9. If we did it right. See, we're just trying to find the common ratio. So watch this. If you divide by 3, you get a 3. And if you divide by 3, you get a, can't do that yet. You got to take the reciprocal. So this would be 12 over 81 times the reciprocal. Can you guys see this? So 9 goes into itself once, and then 81 9 times. 8 goes into itself, 4 goes into itself twice, and 4 goes into that 3, and you can cancel the 3 and the 9, and you get 1/6. So the question is our common ratio 1/6 or 8/9? Do you understand what you're trying to do? Did you understand 15a?
Understood
So you got
15A, but I didn't really know how to do it for the third square.
you have to break it into parts and put the black, what's colored, out of the total number. So you have to count the little black boxes go on the top, and the total number goes on the bottom. Now, when you write a fraction, the definition of a fraction is a total number of equal parts. So that box in the middle has to be considered 9 boxes, right? Because you have to break it into 9 parts, right? So what's the total number of parts, you guys, in the third picture?
81 boxes. For,
And
what I got 17 over 81.
okay, hold on a second. How did you figure out 81? You took one of the boxes has 9. And there's what? 3, 6, 9 boxes? Yes, no?
That's what I did.
Okay. And then what did you get for the number that goes on the top?
17.
And you counted all the black squares, right?
Well, what I did, I divided each square that had the little square into 9 boxes, and then I counted the one in the middle as 1. And then the big middle box, I counted that one as 9 missing.
Right?
And for each one on the top, like, and on the sides, I
So
counted
you
that
did
as 1.
subtraction. So people are going to do this different way. I didn't do it this way, but you could do it this way. So you subtracted how many boxes from 81?
I didn't subtract. I just counted the white boxes.
Okay, how many white boxes?
17.
17. Now, is 17 what goes there? Or do you want the black over 81? Which would be 81 minus 17, which would be what? 64? So which one of these do you want? Do you want 17 over 81? Or
64.
do you want 64 over 81?
64 over 81.
All right. So I erased the thing. So it would be, we're trying to find the common ratio. It'd be 64 over 81 divided by what? What was the one prior to it?
Over 9.
8 9ths? Yes, no? So what would this be? It'd be 64 over 81 times the reciprocal, which would be what? 9 goes into 81 9 times, and 8 goes into 64 how many times?
Times.
So what's that mean?
Common ratio is 8 over 9.
Right. And we did 2 of them to prove it, right? We did the second position divided by the first one, the terms, and we took the third term and divided by the second term and proved that it's 8 9ths, right? So it's number sense, which I have never seen students, just overall, students that have absolutely no number sense whatsoever. It's really weird to me because number sense should have taken place in elementary school. But as far as a fraction goes, a fraction by definition is what you want out of the total number of equal outcomes. So in that third box, you're going to have to split every single square into 9 parts so that you have all equal parts, which would be 81, right? And the numerator is what you want out of the total number of equal parts. That's what a fraction means. So a fraction or a ratio is what you want out of the total number of equal parts. So that's the definition of a fraction. So like if I drew a pie, in order to write a fraction, those sectors, it would have to be evenly spaced. You can't write a fraction that looks like this, because you don't have equal parts. So as long as the parts are equal, so what would that represent? It would represent what you want is 4 out of the total number of equal parts, which should be 8. So what you want is half of that diagram. And you can see that if you put those sectors together, it is 1/2 of the diagram. Okay, do you guys understand how you're dividing this stuff up? Okay. Well, that was probably one of the most important things I've taught all year, because you have to know how to read a ruler in real life. You have to know how to read a tape measure. And so when you're figuring out what size of something you want, remember that when you write a fraction, it has to be out of a total number of equal tick marks. If there's 16 tick marks and you want 4 4/16, if you want 5 tick marks, 5 out of 16. So a fraction, it's always this. It's always what you want out of a total number of equal parts. All right, does that help?
Yeah.
All right, let's is it okay if I teach the lesson?
Yeah.
Okay. All right, we've looked at arithmetic sequence. That is a sequence that has a common difference. We've looked at a geometric sequence, which is a sequence that has a common ratio. And now we're going to look at a geometric series. So this is California Common Core Standard A-SSE.4. And I'm going to give you some definitions here. This is just the definition of a plane series, not geometric. The plane series is an expression formed by adding the terms of a sequence. Now, like I said, this is not arithmetic or geometric series. So series is an expression formed by adding the terms of a sequence. So what about a finite geometric series? Finite geometric series is the sum, and sum means add. It's the sums of the terms of a geometric sequence. So basically what this is saying is, it's saying instead of putting comma, put plus signs, because it's adding a geometric sequence. And this is a sequence that has a finite number of terms. Now, in my notes, I have make sure that you do Explore 1 and Explore 2. So if you do not do this, it's you're assuming you know what you're doing, and I don't know, I would do Explore 2. So it's like a preface to this. All right. First objective, finding the sum of a finite geometric series. This is the formula. Let me explain these parts. So this X, it stands for the sum of the first n terms. So if we want to find the sum of d terms, it would be S of 50. If we want to find the sum of the first 10 terms, it'd be S of 10. So this is the number of terms for the positions. A is the first term, and R is the common ratio. So let's do a problem. So we want to find the sum of a finite geometric series. Here it is. Now, first of all, they tell us that this is a geometric series. So we know there's a common ratio. We're going to need to find it. So let's just do that. So we have 15 divided by 5, 45 divided by 15, and 135 divided by 45. So it's going to be 3, 3. So the common ratio is 3. Now, listen carefully. I know that you could put this on a calculator, but we're not doing that, because if I gave you 200 of them, you wouldn't be able to do it on the SAT. Even if I gave you 50 of them, you wouldn't be able to do it on the SAT. So this is all about practicing in case I didn't give you the easiest problem in the world. Do you understand what I'm saying? So you are not to put a calculator. We're trying to use the formula here in case we had a bunch of terms. All right, so let me write this down. So all we do is we count the number of terms. In this case, there's 6. So wherever you see an N over here, you put a 6. So this would be the first term is 5 times 1 minus, the common ratio is 3 to the 6th over 1 minus 3. Pay attention. Negative is not part of the power, and we really attend to precision. So this is going to be 5 times 1 minus, and do 3 to the 6 on the calculator. So what's 3 to the 6 on the calculator?
$729.
729. Over a negative 2. So what we have here is 5 times a negative 728 divided by a -2. So what's a negative divided by a negative?
Positive.
Positive. I'll show you how to do this, because last period I spent a lot of time doing this. People didn't know how to multiply, so watch. Just watch. This is 728 divided by 2. So this is how you want to do it. You want to multiply. So just like how we do a GCF and we upside down cake, it's kind of like Price is Right. 2 times what is 7 without going over? So 2 times 3 is 6 with 1 remainder. So now 2 times what is 12? 6. 2 times what is 8? 4. 364. I see it again?
Yes, please.
Two times what is 7 without going over? What's the remainder? Two times what is 7? It's 3. What's the remainder?
1.
1.
So put the 1 there. 2 times what is 12? 6. Times what is 4? Let's do another one. Look over here. Let's do 1024 divided by 4. I don't know if it's going to go in evenly. Let's just see. 4 times what is without going over?
2.
With 2 remaining, why, right?
Yes.
4 times what is 22 without going over? 5. With how many remaining? 4 times what is 4? 6. Follow that?
Yeah.
Do you want me to do it again?
I think I'm good.
What about everybody else?
Yeah, I got it.
I got it.
So this, what I just showed you is not how I learned it. So when I was getting my master's, I was with a bunch of elementary school teachers, and elementary teachers are afraid of math because multiple subjects. They're not math. They asked me, Roxanne, how do you teach division? And it's like, I don't. So I showed them this because I said students can multiply, but they can't divide. So just teach them multiplication whenever you can. Always do this, but when you can, like this, do it. So in this class so far, for months and months, you've never really seen me divide a whole lot. You always see me multiply. All right, so they could put this on the calculator. So you could put the powers on the calculator without the negative, and you could put this in the calculator, nothing else. Everything else has to be done by hand. So what's 5 times 364?
1,820.
1820. Now, I want to show you something else. There's a bug flying in front of my face. I want to show you something else. Do not put that negative in the calculator. You know that a negative to an even power is positive. And you also know that a negative odd power is negative. So don't put negatives in the calculator. So this would be minus a positive, what's 2 to the 8?
256.
So you see, I only put the 2 to the 8 calculator. So it's 1 minus a positive 256 and 1 plus 3. So this would be what? A negative 255 over 3. And now we can see if this divides. I don't know if it's going to simplify. Let's just see real quick. 3 times what is 2? Nothing. 3 times what is 25? 8. With 1 remaining. So isn't that a negative 85? Yes or no? Do you see how I did it? 3 times 8 is 24 with 1 remaining. 3 times what is 15? 5. And if it didn't work out, you would have left it like this. But it did work out. So you must simplify. Let's try another problem that's more interesting. Do you guys have any questions about this before I erase it? The answer was 1820. This is the last problem. And now you're going to see why I want you to work together. Because if you work by yourself, it might be mistake after mistake after mistake, and it takes, 5 minutes to do one of these problems. So here it is. It's 1/4 plus 1/8 plus 1/16 plus ... So there's missing terms plus 1 over 5/12, but it is finite. So here's the issue. We don't have any terms. So before you do this, no n, so you can't do it. So here's what you do. You're going to take your rule, your implicit rule for a geometric sequence, and find out terms you have. So watch. You're going to take the last term, which is the final answer, 1 over 5/12. And that's what it is, right? It's y, the answer. The first position is going to be 1/4. We're still going to have to find a common ratio. So this is going to be 1/8 divided by 1/4, 1/16 divided by 1/8. So isn't this 1/8 times 4 over 1, which is 1/2? And isn't this 1/16 times 8 over 1, which is 1/2? Did you follow that or no?
Yeah.
You guys okay or no? So what we have here is we have an exponential equation, and we have to get him down. Now, do you remember the rule that I gave you the other day that we haven't learned yet? And I said, if you have b to the m equals b to the n, then m equals n. Remember that? So watch what so it goes away. And I'm going to multiply this by 4 And now I'm going to make this, well, I'm going to simplify this. So divide by 4, and divide by 4 would be a 1 with 1 remaining, which would be what? 128. Divide the top and the bottom by 4, right?
Yeah, that's right.
Okay, and so I can write my base half to what power? So 2 to what power is 128?
Two to the 7.
So 1 to the 7th is 1. 2 to the 7th is 128. These are equivalent, right? And I got the bases to be the same. 7 is equal to n minus 1, which means n is equal to 8 terms. So now I'm ready to do the problem. So we have s of 8 is equal to the first term times 1 minus 1/2 divided by 1 minus 1/2 . So that negative is not part of the power, right? So what is 2 to the 8th? Two to the 8th.
256.
56.
Now watch this. Since I'm subtracting, that negative is not part of the power, right? Since I'm subtracting fractions, I'm going to make this one 256 over 256 because I need a common denominator. And I'm going to make this one 2 over 2. Do you follow what I'm doing? So what you have here is 2 minus 1 is 255 over 256 minus half. And I wrote divided by me. I wrote it like that because to make the problem easier. So we have 1/4 times 255 over 256 times the reciprocal, and we're going to cross cancel. So 2 times what is 2, 2 times what is 5 with 1 remainder, 2 times what is 16, 8. So we end up with 1/4 times 255 divided by 128. And by the way, if you cannot cross cancel, you're done. So the final answer would be 255 over, what's 128 times 4?
$512.
So that would be your answer. That would be an exact answer. Do not give me a decimal. So this is an exact answer. Okay, now I kind of have my screen shifted down, so let me know if you have any questions over here. So let's start here. Anybody have any questions about how I found the number of terms? You have to use the rule for a geometric sequence. And the only way I taught you right now, the only way to do it is to set the bases the same so that you can get the n down from the power. So last call. Anybody have any questions here?
Why is f of n 1 over 512?
Because we need the 1 over 512 to find the number of terms. If we use anything else, we won't be able to get the terms. We have to use the final term to find the number of terms.
Okay.
Anything else? Okay, let's go back over here then. Anybody have any questions about anything over here? Okay, what we're gonna do is class is over at 12:10, but I want you to go to your Math Wizard teams and I want you to do problem number 6. So on the practice AB in your team, I want you to try to do problem and see if you can get the right answer. Okay? Number 6 is similar to this one. It's not complicated because it doesn't have those fractions, but you're going to do number 6. Any questions? All right, I will be taking attendance in the Math Wizard teams. We will not be checking back here, so if you have questions, make sure you 6 on practice lesson 12.3. All right, I'll see you in your teams.